Recap? There you go. Previously on. All right, take it away.
So when I talk, I'm a pacer, but this is going to be my first time using the code on live here. I can't both write on the keyboard and walk around. So bear with me if I wander off and then have to come running back. I apologize. Yeah, so like John said, this is a continuation, sort of spiritual successor to my talk last year. That was more of a story. This is going to be more practical application. The biggest piece of feedback I got on that talk was that there were no code examples. This is going to be basically one giant code example. So yeah, my name's Brad Dillon. I work for Possible Mobile. I'm a mobile architect working on apps for big brands, and I've learned a lot of things about architecture that I'm hoping to share with you guys today. So yeah, agenda real quick. I'm just going to recap very quickly, hopefully very quickly. I tend to be long-winded. And then talk a little bit about MVVM and Swift, and then show a bunch of code, and I'm going to rely on you guys to come up with some really good questions for me to answer and discussion to be had. The code, I'm going to go ahead and put this up here now. If you want to get it to follow along, you can. It's available now, public. I sure hope I made it public. But it's up there on GitHub, and if you want to just jot that down and get it later, that's cool too. I'll explain, I'm going to walk through the entire project for the most part, so you can get it now if you want to. Anyway, so yeah, last year I spoke about how I accidentally discovered MVVM. For those, let me back up actually. Who has heard of MVVM aside from me? Okay. And who has used MVVM in a project? Cool. That was more than last year. So I came up with, yeah, as someone said, C#, yeah, that makes sense. I came up with it, when I say I accidentally discovered it, what I really meant is I basically just came to some of the same conclusions that the people who do MVVM had come to as well, and sort of structured some applications that way. It seemed to work really well. One of the reasons I think this is such an important topic to sort of get a grasp on, or at least a design pattern to at least look closely at, is as we start getting more and more different types of hardware that we have to code for, watches, for example, and TVs and cars, being able to port code from place to place is going to be really useful with your apps. And this, I think, helps do that. So, recap from last year. Everybody should be familiar with MVC. If you're new to iOS development, you may not be, but you actually are, whether you know it or not, because you have at least come in contact with UI View Controller. UI View Controller is a controller object that faces sort of a view layer rather than a model layer. And the biggest problem with view controllers, and I'm not the only person with this slide in my deck, is MVC has come to be known as, stumbled over that exact same phrase last year, massive view controller, which basically just means that people tend to stuff lots of things into view controllers that they're not weren't really intended to be stuffed into them. Things like networking and stuff like that. View controllers tend to be subclassed often, especially when we're dealing with things like iPhone and iPad or anything like that. We tend to do something like this. This is just a common use of inheritance for using view controllers when they've been overburdened. We will have an inherited superclass that communicates with a backend or model stuff. And the problem with this is over time things sort of drift apart, your requirements change, and you end up with spaghetti code and an enormous view controller. And the problem, this isn't good MVC, right? This is bad MVC. So you can do MVC and not end up with this, right? But my experience with MVC before discovering MVVM was that. MVVM is like a layer on top of MVC. I'm going to re-quote Ash Furrow here. He said that an augmented version, that MVVM model view model is an augmented version of MVC where we formally connect the view and controller and move presentation logic out of the controller into a new object of the view model, which is a fancy way of saying it looks like this, especially in Cocoa. So in Cocoa, you have, well, you had MVC There's your view and your view controllers and your model over there. We insert a new type of object in the middle there. That's the view model. And when he said, formally unify the view and the controller, basically they just look at the view and view controller as one entity, which makes a lot of sense because the view controller is generally a screen full of information, or on an iPad maybe a smaller screen full of or a portion of that screen, and it has a single view that it controls. So unifying those two into one object kind of makes sense. So this is the way that you would typically, I showed you an inherited model earlier. This is the way that a MVVM developer would see that same kind of problem being solved. You have view controller, one or more view controllers connected to a type of view model that is, generally speaking, has a one-to-one relationship or one-to-many relationship with view controllers. And the view model is responsible for communicating and doing all that modeling stuff. When I say modeling stuff, what I'm talking about is like, okay, it's a view controller that is supposed to display a list of, as we'll see in my example, conference sessions. Where does it get those conference sessions? The view controller doesn't need to know where those came from, right? It doesn't need to know about core data. It doesn't need to know about the web services. It doesn't need to know about any of the security that you might have going on. That should all be encapsulated in something else, and a view model is a good place for that. View models are easily tested, composed, refactored, and replaced. I want to spend a bunch of, I could spend tons of time on each of these, and I'm not going to. But I'm going to, the testing one is extremely valuable because view models aren't tied to UI. They're more of a conceptual object. And if any of this is, if you have any questions at any time in this, by the way, just please jump in, although I will have, hopefully the code will answer some questions that you might have. View models are easily tested because you don't have to spin up an entire app in order to use them, in order to test them, right? A view model's job is just to go fetch some data and then output that data in some way for a view controller to consume, or not necessarily a view controller, but some other kind of object. And in a unit test, that's perfect because the unit test can be that other object and just consume the view model and basically get the data, test the data, you know the state of the data should be based on your testing harness, or if it's a service that you know well. And so you don't have to spin up an entire navigation controller that depends on a tab bar controller existing, and your app crashes because your test harness doesn't quite match a real-world app scenario. These kind of things can get really frustrating. View models sort of alleviate that by not needing an entire app and UI to be set up. By composed, composability of view models, what I mean is you can have view models that depend on each other, which I'm going to show better in an example later, so I'm just going to go past that. Refactored and replaced. This is my favorite part of this. This is my favorite part of this. I have an application we're working on right now that it originally was just an iPhone. By the way, a different iPhone, a different app from the one I told about last year. We had an iPhone app that was invented, that was created like 7 years ago before core data existed, and then an iPad app that was created separately that was built obviously after core data existed. So they were the same. They were consuming the same backend, but they were turning that data into two different databases. And then we unified the app into a universal binary, but they're still two very different experiences because we never had the time to really throw one of those data models away. So we had one app with two backends. If you're running on the iPad, you're hitting this one. If you're running on the iPhone, you're hitting this one. It's a mess to try and detangle these because it was all done in the view controllers. Well, what we did is we went through the entire app and refactored all that communication to be done in view models, and then we were able to just kick one of the view models out from under the view controllers. The view controllers were built to communicate not with core data and not with NS coding, but to communicate directly with a view model object, which it knew how to do both of those things. So then we just removed one of those code paths, and it actually just worked. It's like 90% work, right? So there's always going to be work there. So yeah, huge fan of those two benefits. So if there's one easy way to think about view models that I've learned when trying to, this is the way that I use. I run all of the applications that I work on. All my projects use MVVM in some degree or fashion. And so when I'm onboarding a new developer, I think the thing that I've learned is the easiest way to help them sort of grease the wheel, make this easily understood, is to think of things this way. Your view controllers are about user flow through the app, and view models are about data flowing through the app. So they don't have to be one-to-one matched. You're separating those two concerns out. So the view controller is just responsible for UI, just responsible for the user getting around in the application and getting views on the screen. And the view models are responsible for marshaling data through the app from the back end to the front. Some examples, not code yet. Let's say we have a view model that's driving a table view control. That view model is going to have methods on it that are something like number of items, which the table view controller would then translate into number of cells. It's going to have the item at this index. But what it might also have, with a table view controller, you have a bunch of table cells that are then, owned by that view controller. The view model would then have a bunch of sort of child or sub, maybe row level view models. And then you can actually hand those view models to the table cells. And it's a lot less dirty than if you actually handed a model object to a cell, right? Because if you're an MVC absolutist, you don't want your models to touch your views, right? They should never have, you shouldn't cross that boundary. View models are great for that because my table cell doesn't know anything about the backend, doesn't know anything about the model object. It only knows how to communicate with an object that looks like this view model. And with protocol-oriented development and design, this is even easier because it doesn't even know what kind of object that is. It just knows it's going to get its information from an interface. The reason this is different, one of the other pieces of feedback I have received when talking about this in the past is that this sounds a whole lot like a data source, right? Because table views have data sources. You could just have extract that data source out from a view controller so that it's some other object, and you solve this same problem. That's true and it's not. It does solve the same problem, but it doesn't solve this problem. Let's say I need to move that over from a table view controller to a collection view controller. I want a grid instead of a table. If I had just extracted it out as a data source, it's tied to that table view because it's using that protocol that the table view is expecting. But by doing it one level further back, I'm able to basically reuse those exact same view models for a completely different type of collection, or a completely custom view. I could have a parent view controller with just some, my own containment that I've set up that has nothing to do with these, existing Cocoa things. View models allow you to do that in a bunch of different ways. Like I said, by separating, this is the flow of data through the app from this is the user experience of the app, you get the benefits of being able to decouple those things that way. I don't know if that's making sense. Benefits of MVVM, just recapping again, this is all still recap, like 15 minutes in. Works well with MVC, naturally pairs with view controllers, refactoring, and yeah, it's by doing that separation, it helps avoid massive single view controllers and unit testing. What I didn't talk about last year at all was Swift, because Swift was at that time 4 or 5 months old, and I was using it, but I wasn't really comfortable talking about it. I don't think anybody else was either. MVVM and Swift are awesome. I just typed in awesome GIF, and this was the first one that came up, and I was like, I don't need to look at it. No, it's really awesome. Some of the benefits here are, protocol-oriented design allows for even further decoupling. Generics loosen couplings that were there before. One of the common ways to use MVVM is, and Objective-C would have been through bindings. So if I have a view model that's attached to a view controller, I would bind labels. Obviously in iOS, it's different from on the Mac, but I would use some kind of binding agent like KVO to basically connect this label with this string and this label with this date or whatever, so that changes would be reflected in the UI. KVO is not really great for that. I mean, it is great for that, but it's also really heavy, and it has a whole bunch of old stuff, and it's not very clean. Generics plus this did set and will set observers that are built into Swift just make that super easy. Really lightweight. There's probably some limitations. There's definitely some limitations. KVO has a lot more to offer, but I'm going to show you in my code that this helps a lot. Makes this a lot easier. I'll talk about this last point with somebody here. Centralized optional handling. If you've ever asked yourself, like, you're working in a view controller, and it's like, where should I be dealing with the fact that this thing could be nil? The view model is a great place for that, because as you're getting data that's coming up through you don't want to handle it in the database because you want to be true to whatever service you're getting your stuff from or whatever the user entered, so maybe that is nil, and that's fine. But as it gets closer and closer to getting to your UI, as soon as you try to stick nil into a label, you're going to get that. Anybody ever seen like a label in an app that has parentheses null because no one sanitized their string? That's because someone tried to stick nil into a string formatter, and it just does that. The view model is a great place to handle that and say, okay, the view controller will not get anything optional. The view controller only gets non-optional values, so that the view controller doesn't have to worry about crashing or displaying anything weird. You can handle all those cases at this lower level. So let's jump into code. There's that URL again if you're interested. And I'm going to, so there's a whole bunch of stuff in this. I did an app and wrote a couple of apps here to demonstrate this stuff. And the apps are sort of real-world examples. So there's networking, and there's a JSON feed that is actually a web service that I built for this. It wasn't that hefty. So there's a bunch of stuff in the app that I'm not going to cover because it doesn't have anything to do with MVVM. So I'm not going to go like class by class through this. Let me run the app first. Take a look at it. All right. This is running on, I didn't want to run it on my iPad. Let's start with the 6. Any questions so far? I'm going to be asking that every time I hit compile because Swift tends to take a while to compile.
You tell a story.
I told the story last year. Okay. So here's an app. And again, it's a conference app is the idea. It's a conference all about doing stuff. These are some of the talks. This is what the most contrived example of it. Like, here's some talks at this conference. And then there's a tab that you can't see because I'm running on a 6+, which is a bad choice. And here are the speakers, right? And so when I drill into a speaker, here's that speaker happens to be a cat, and list of the talks that these speakers are giving. This one's giving 2, and so forth. If I go back down to the talks, I can drill into the talks and get some details about those talks. Now, I will also add, if I go to the iPad, that did not take long at all. That was nice. On the iPad, it's a totally different app, or at least different UI structure to the app. We have a view that looks similar to that talk detail at the top, where it's actually the whole thing, and then the author is down here. This gap in the middle we're actually going to fill out later in the talk. But this is not a table at all. It's also not a collection view, like I mentioned in my slides. This is a page scroll view, or page view controller. Okay. Which is, from a UI perspective, extremely different. Conceptually, it's actually very similar, right? Because these are actually, it's still showing you a list of information and then details about each item in that list. But it's not requiring you to drill down like you do in a table or a collection. You're not having to drill into the next level of hierarchy. But if we talk about the flow of data through the application, that is very much the same. For talks, we start with, there's a list, and this is very similar to the JSON feeds that are included. There's a list of talks, and then there's talk details. And there's a list of speakers, and there's speaker details. How we surface that information in the app is not necessarily related to how the data flows through the app. So let's take a look at let's take a look at that question of how data flows through the app. I want to look at, for starters, we'll just look at our model objects. They're real simple. Oh, that's not it. Forgot core data does this fancy new thing where it puts them in these categories. Data model is really simple. A speaker has 4 properties and a set of talks that they're going to give, and a talk has 5 properties and a speaker. Very, very simple here. So when we look at our flow of data, I mentioned before, I want to do everything as much all about protocols as possible. That was not the protocol. There you go. I put all the protocols in one file just so we could look at them together. I started off with a protocol called refreshable, just so that everything in here can be refreshed and pulled down from the feed if I need to do something like pull to refresh, or just need to refresh on view will appear or anything like that. We'll come back to that. But I have a talk list, and that talk list has a method called number of talks and a method called talk view model at index. Now remember, I want the consumers of these view models to never interact with the model objects themselves ever. I don't want them to see core data. I don't want them to know core data is in this application, because I want to be able to remove core data and replace it with something else in the future, or change to not using core data, just directly using the web service or whatever. I just want to decouple those things as much as possible. So by doing this, when I call this is going to return a talk view model protocol object, which is right here. And that just gives me a talk title. Remember, in that initial list, there was nothing more than a single title. View models being more focused on the model side of things, they're going to be somewhat influenced by your web services, right? And my web service has a list service and a detail service for talks. And so this is an object that returns, like, I've only had to make one request to get these two view models that match these two protocols, if that makes sense. Again, view controllers don't know where that data comes from. It just knows how to consume these view models. Once I've got one of these talk view models, it's like the table cell, going back to the iPhone example, I can then ask for the details for that. And that's going to give me the details view model protocol, which is here, which just surfaces each one of those other properties. Now, at some point here, you probably noticed that I have this thing in here called dynamic. I'm going to cover that in a second. This is part of that generics and did set, will set magic that I love Swift for, something we couldn't have done before in Objective-C. But at any rate, one thing I wanted to also draw your attention to related to the view model is, if we go back to my talk, notice that the talk model object here has an NS date. I can't put that in the UI, right? This is one of the things that sort of led me to look into this design pattern in the first place. I can't put NS dates in the UI, right? I need to put that in, I need to turn that into some kind of a string or something to display to the user. Maybe a couple of strings in this case. So, because just to remind you, if you look here, I've got two labels here, 2 different lines, one's the date, one's the time. That could have been done anyway. I could have been using that to group things or whatever. That's where the talk details view model is handy, because it's not going to return a date to its consumer. It's going to return a string for date and for time. So there's a certain amount of understanding of what I'm going to need to present to the user. And maybe if I needed a situation where I need both the date and time in one string, there'd be a third option here. Formatting is not the cheapest thing in the world, but it's something that we can centralize here and not have it spread all over our view controllers. Yeah, so you can see, if you wanted to take a look at this yourself, you can look at how speakers work. The speaker list works. It's basically the exact same design. Now let's take a look at the actual view models themselves. They're ridiculously simple, because this is a contrived and simple example. Here's my concrete class of talk list view model that conforms to this protocol. You'll notice it's not a subclass of anything. I didn't want to be bound to anything specific, and because I'm using all Swift in this case, I don't need to subclass NS object or anything like that. It has a couple of private properties on it, talks and a store. The store object is implementation detail for this app. It has a refresh method, which calls a fetch talked function, which is, again, implementation detail. That's what does the networking stuff. It then receives those talk objects and sets it and then calls a completion handler. And then at all times, number of talks returns the number of talks we have, and talk view model will construct a view model for the index that's requested. That talk view model is down here. So number of talks, notice that I'm not having to do anything with optional values because talks is not optional. It starts off as an empty array. So at no point is talks unknown. It's always known. It's either going to be empty because we haven't fetched anything yet, or it's got native. So I'm handling optionals here as well. So before I go into anything else, I wanted to go ahead and take a look at, actually I want to look at talk details real quick, and then we're going to go into the unit tests. So here's talk details view model. It's basically as simple as the last one. The only difference is that you hand it the talk that it's going to represent. It needs to have been handed an object to format and to make requests on and so forth. Basically, we start off by giving it either, if that talk object already has values, we're going to give each of these. I haven't talked about that yet. We're either going to have a name, or we're going to go ahead and use a blank string in this case. That could be any other kind of placeholder we want. If we don't have data yet, we could have loading or whatever you want to do there. Handle that however you want. The view controller is only going to get formatted string value for each one of these values. Okay. Refresh works exactly the same way as the other one. Once we've gotten back a talk, we refresh this talk, we get back an updated talk, and we're going to go ahead and update the values for each one of these things. Got our date formatter and our time formatter. They're local to this property, or to this object. They're lazily loaded properties. That's part of it. So now, I want to show you guys the dynamic thing, and then I want to show unit tests. Up to now, aside from dynamic and unit tests, any questions? Anybody lost? Go ahead.
Maybe we'll get into some.
Yeah.
Can you scroll up? How is while you're passing into the speaker details model, is the store, does it know which talk when you're initializing that details model?
This one right here?
Yeah.
Yeah, that is a great question. So that is part of the map. Yeah, I tried to fix that. I tried to make this a little bit more elegant. The problem with it is because this is intended to be a service-driven app. I don't have the speaker. I may not have the speaker at the time that this object is created, that this talk details view is created, because I haven't fetched the details for this talk yet necessarily. Right. So I can create the speaker details view, model, but it's going to be returning blank information until it's been given a speaker to go fetch. Does that make sense?
Okay.
So what's
it's kind of a lazy visualization.
Exactly. Yeah, and it's, if you look down here, right here. So once I've fetched the talk and I've got the details for the talk, I also know what speaker is related to this talk.
I didn't see that.
Yeah, so I've got the speaker, it's been created in core data, and I'm setting that speaker to the details view model, and then telling it to refresh and getting the details on that speaker that I may not have gotten in this initial fetch for the talk. Okay. Was there another question? Yeah.
How do you map between your view model to the domain object and domain object to the view model?
That's the dynamic object. So you mean with regards to how the values change?
How do you that like you have a view model, how do you map it to the core data model? Core data model, does it map back to a view model?
Not sure I follow with the word map. There's not necessarily a map because a view model might consume multiple model objects in some cases. One of the apps that I work on, it consumes a whole bunch of different services and has to take all the model objects and turn them into a visual, like some concise data to be presented to the user. So the view model is actually, in that case, responsible for like 5 different types of models, and then combining them together into something for the view controller or whatever to display. So there's not necessarily a one-to-one map anywhere here, except between usually the view controller and the view model. Does that make sense? So let me show you the dynamic thing real quick. I've got this down here in detail. I didn't write this, and I tried to find where I got it. I didn't get it. One of my coworkers found it and showed it to me. If you know where this is from, I want to put the attribution in here.
I think I know where this is from, because I think I just read it.
Okay. All right. I want to put the link in the talk notes, so if you can give it to me, or email me or tweet me or something. But it's a really simple idea. Basically, this is a class that uses generics to represent a value and then notify or call a closure when that value changes. So it's got a listener, and that's just a closure, and it's got a value. And when value gets changed, this did set observer gets called, and listener will get called if it exists, passing in the new value. And so then it provides 2 functions here, bind and fire. And the only difference, basically what these both do is they allow somebody to hand a closure to this dynamic object to fire. And in the case of bind and fire, go ahead and call that right now as well. So I want to go ahead and I'm going to hand you this closure, and you're going to fire it right now with your current value, and anytime that value changes in the future, you're going to fire it again. So the idea here being, if I'm a view controller and I'm trying to let me just go ahead and jump in right into a view control so you can see this in action. If I look at the talk view controller, I have these 5 labels right here, and I have my view model. And in view to load, I'm just going into my view model and saying talk title, bind and fire, and then here's what I want to happen anytime talk title changes. And I'm just changing name label text to the value that came in, the new value. Right? So this is a really simple one-way binding. So anytime talk title changes on that view model, the label is going to update, and it's going to happen right now so that my label gets an initial value right now with whatever that value is. So going into unit tests, not that one. So when I did this, when I wrote this sample project, I didn't write any of the UI. I wrote the view models first, and then I wrote unit tests. I didn't write all of them. I just wrote enough to give you an idea. Then I went and made sure that those were working, and then I went and built the UI. Right? It's sort of the way the unit tests are supposed to work, right? Although I guess I actually did it. Let's write unit tests first, then write code. But I've never been able to get that working. But yeah, I'm not going to go into too much detail. I'm not a unit test. I'm not a huge big fan of the idea of unit tests. Don't end up using them as much as I'd like to. So if you use unit tests regularly, this will probably make you cry. I'm doing asynchronous. I'm unit testing against the service, but it's a service that's running locally on my machine, so I know exactly what's coming back. But anyway, you're not supposed to do that. At any rate, I'm testing that these view models, again, I'm using view models as if I were a view controller and testing that they're behaving the way that I expect them to. And the view controller never had to be initialized. The only thing I had to do is create a store object and create a view model and hand it the store. And then I could technically navigate through the entire app using these view models, using the flow of data. So I could say, start from my talk list, drill down to a talk detail, get to a speaker detail, and ensure that my data is existing and getting carried through all the way to the end. Right? I could navigate all through my quote-unquote app without ever actually initializing any UI. Right? So then, the only thing I haven't tested is the actual UI. And the UI is so simple that, I mean, that's, granted, you can screw up anything, but that's a lot harder to screw up than having done it all in one class. Okay, so that's unit tests, and that's dynamic, and okay. Any questions at this point? Yes.
Yeah, so the binding here is one way. If we had trouble with two-way binding in a couple of different apps, and we tested it. How do you feel about two-way?
So, it's a good question. The problem with binding is, well, I'm not going to say something that Randy is. The problem that I've had trying to implement bindings in the other direction is if I'm trying to take user input and feed that into a view model, every piece of UI that is for user input is very different, right? So like for the text field, you have to implement a protocol. For a switch, it's a target action, and so forth. The segment control, so target action, all these different things are target action based or protocols. It's different. If you have a table, you have another protocol. So it's much more complicated to be like, anytime anybody does anything to any of these UI, make these changes, these very simple two-way binding changes. You have to just like subclass each of those pieces of UI. I think this is part of what like reactive Cocoa does with signals and stuff. It allows you to do these two-way things. I've just never done that, right? If I have to do the other way, I've done it manually and just had the view model do the right thing in the back. So where I might not, if my view model is taking user data and then persisting that in some way, or sending it to a service or something else that the view controller doesn't even know about, then when the user hits done or something, like they've entered form data and they hit done, I'm going to tell my view model to save, and it's going to do whatever it needs to do. Just like right now, I tell the view model to refresh. You'll notice right here, the last thing I do in view mode is refresh. So that's telling the view controller does need to at least in some way let the view model know when it needs to take certain actions. Refresh, save, something like that. So binding in the other direction, I've never seen an implementation that I like. So I just do that more manually. Does that answer your question? Yes.
Here you're defining the UI to changes on the view model. And this is all happening in the main thread, right? Because you've got UI updates. But if you pull data from your data source, that's going to be the different thread. Right? You're communicating with the server. I know you haven't gotten that far yet.
Well, here I can show you actually. This right here, fetch talk, that goes to a background thread, but this is part of the implementation details that you can see. If you go and dig into the services and how I built this, not really part of the scope of this, that's happening on the networking is happening on the background thread, but it's calling back to the main thread.
So that's how you are updating in real time. But what I've implemented a very, I'll call it a formatted version of this. Updating a whole data series. Actually drawing a chart, for example, in the main UI with data that's coming back from input over the network. What we ran into was that if the user made changes to the UI while we were drawing the chart, and at the same time we were pulling data, you ended up getting part of the chart or mixed data on the chart. So we had to be careful about the concurrency issues there. So since you're waiting for the endpoint to come back completely before you draw it,
So I haven't done what you just said, where the user is interacting with it at the same time that you're pulling something. But I have had an app that had to pull, like I mentioned earlier, a bunch of different data sources to implement a single UI. And in that case, the requests were being made asynchronously, and one would finish, and then the other would finish. And I would update the UI halfway, and then again when the other one would finish. It would be really odd and jumpy. And so in that case, I implemented something where the view model would basically check to make sure it had enough information and was in a state where it could tell the UI to change. So in other words, if something was still in process and it's not finished yet, I need to wait. And I need to wait until everything is done before I refresh my UI. So I don't know if that would...
Yeah, that is exactly what I'm talking about. I did it at this level.
Exactly, in the view model. Yeah. Yeah, so the view model would basically it would mark itself as dirty until everything is finished, and it would not refresh its UI until it was not dirty.
We've solved that problem using a concurrent queue, but it's a little ugly. You've got to know when you're entering and exiting the concurrent queue.
Yeah, I've toyed with the idea of having each view model had its own queue, and I've watched the NS operation, the advanced NS operation talk at WWDC, and just blew my mind. And so I've toyed with the idea of each view model having its own queue and then being able to just pile up, fill that queue up with a bunch of stuff and not do anything until all those are finished. Haven't done that yet, but it would be another solution I can see. Okay. So I showed you a second ago. Oh, one other thing I want to show you. The list, the talk. Okay, so going back over here to the talk list view controller. The talk list view controller, I haven't shown you this yet. So this was, like I said, there's a list of talks, and in the iPad it was that page scrolling view controller, and on the iPhone it's a list. So again, the view model that's responsible for the talk list has just a couple of methods on it. Number of talks is the first one, and talk view model at index. So all I do in these cases is, number of rows becomes number of talks, or it returns the value of number of talks. If I look at the page view controller here, it's the same kind of thing. I have, well, it's a little different because of the way page view controller works, but suffice to say, I use the exact same properties on the view model in order to construct the page view controller. Let me go back here real quick. Not there. Here. The other thing I want to throw out here is that I've got this cell. My cell is actually, the table cells are handed view models themselves, right? And they're bound to the same properties on it, or a property as well. Its label is bound to a property on the view model that it has. That's going to become more interesting in a second. So at this point, I've got this app. It works. It's using view models. It's unit testable, which is really nice. We're doing two different pieces of UI, very different UI. This isn't necessarily something that would be super easy to do using size classes because they're two completely different set of presentations. But let's take a look for a moment at another benefit of view models I haven't talked about yet that I really enjoy, is being able to mock up new features without actually having the backend for them. So this happens to me quite often. I'll be asked to implement a new feature in an app, and the web service for it doesn't exist yet. So we just need to get started, and we know what the service is going to look like and feel like, maybe, but it's not built yet. It's really frustrating and irksome to do that because, as a developer, I would like to be able to know that when I build this UI and then they turn on the back end, it's all just going to work. View models are really nice for this because I can basically do the UI part of this and make sure the UI part is working exactly the way it's supposed to without ever actually having a back end working. So the way I would do this is, let's say, for example, that going back to here, let's say that this conference is going to have videos. They want to have videos of each talk when they're available. And the video is going to be in this giant, big white area right here. But the video service doesn't exist yet, or they haven't been uploaded to, we haven't chosen the video provider yet, or whatever. That's great. We can do this with view models pretty simply. I'm just going to go in here to my talk detail view model and add a stream URL property, because I know at some point I'm going to get a URL. Let's say that's at least the most I've been able to get out of whoever's giving me the requirements for this thing. So then I can go in here to talk view controller, and I can go ahead and I can go into my storyboard, and I can build a container for that video, and I can, in my view controller, go ahead and bind, keep jumping ahead. In my talk details, I can go ahead and throw in a little sample code here that I just add this property to conform to the protocol for the talk stream URL, and I go ahead and give it a value when we refresh. I'm just going to go ahead and give it a test stream value from Apple, just so that I can go ahead and build the UI. So now, my view controller, all I have to do is bind to that URL and use it as I expect to. And if we run this, it'll work. And real quick, that's the talk. This is actually the iPad or the iPhone code. The iPad code looks like this. So all I'm doing is giving a video player controller an AV player hooked up to that stream URL. So there it is. This great big clip. So the benefit to this, or the reason I'm hyping this as being a very useful thing, is that I no longer have, once those services are plugged in, and I have to build a JSON parser, and I have to hook up my data model, I have to put change core data so that I can store it, and I have to get my view model to actually get the right value. But my UI is done. I don't have to change anything here because my UI is separated far enough away from all that stuff that it doesn't need to know about. So if I look at the way that it was implemented on the iPhone, it's a little different. Because if we look back at that code, I'm just putting a play button. It doesn't have the exact same UI, so I just put a play button up in the top right-hand corner. Get my talk list. This play button right here. Does the same thing. But again, the UI stuff, it's now done. I don't have to do anything to that. So I can get sign off from the client. I can do whatever else I need to do to proceed to getting that service built up. Okay. One more example to show. Any questions about that while I switch pages? Okay. Okay, so this one is a little different. So let's say we have another new requirement, and that is that we would really like to have a today extension that shows the users the sessions for today that the user has. Well, let's just say the sessions for today. I don't do anything with favorite yet. There they are. It was really easy. The way that I did this, again, is because I'm not tied to a specific visual implementation, I was able to use that same view model that was showing the list, also coupling in the details where the room and the date come from, and here's what that looked like. Didn't really change anything in the view model itself. I did have to move everything out into a framework, by the way, to do this, just so that I could link it to you. I could have just included it twice, but I did include a bunch of stuff twice. So the today view controller is, again, pretty simple. The view controller does the same kind of thing that the list view controller does. It returns a number of talks and grabs a view model for each one of those cells. But then the cell has more information on it. It has title, location, and time label. But again, because the view models are the flow of data through the app, I can get to the details for that view model right here. So I go ahead and bind to the detailed view model's date and location, and then tell it to refresh. And for each one of those cells, it's going to have to make a web request in order to get that data. But once it does, it'll have all that information. Each cell will have all that information at its fingertips, and it'll just update when it comes in. So in this case, I am the cells. Each one of the cells is asynchronously through the view model that it owns, making a quick request to get the details, since that's not an initial view model. This is a view controller. My iPad example was a view controller. My iPhone example was a view controller. I wanted to do a watch instead of an extension, but Justin pointed out several times today the watch simulator is really flaky. So I scrapped that idea. This is my first time doing code on stage, and I didn't want to mess myself up too much. So watch extensions and apps don't use UI view controller. They use watch kit. It's totally different. Well, I mean, it's very similar, as we saw this morning, but it's not the same. You can't just subclass your view controller again and get it on a watch. You have to write something completely new. And the view model helps you sort of alleviate at least some of that by going ahead and having those views, not views, but the data for those views surfaced for you, so that all you have to do is hook your watch kit interface controller, whatever, those controllers up to this. There's another one that was recently released that I'm not going to talk about because it's in beta, but like tvOS, right? I mean, it's a whole new platform, and the same kind of thing is true. It's going to be, it's got a bunch of the same stuff from iOS in it, but not all of it. And you're going to be doing some redesigning of your apps if you're going to start using, want to work on tvOS. But again, the view model portion of this app, the framework that I siloed out here, that should all just work because it doesn't have any dependencies other than the networking and core data. As long as you've got those two things, then this stack can run basically. So yeah, so that's about it. That's it for my coding example. Is there anything else in this project that you'd like to take a look at before I switch back to keyword and close it?
One sort of style question. The approach here, you have a list of bindings. You have each value is dynamic for each value. I was curious if you've ever tried sort of doing the binding at the model level itself, because it seems like a lot of times sort of everything changes. So you could have this view model .bind and then have a callback that sets all of the view labels and stuff from that state. And is there sort of pros and cons to that kind of versus doing it in each individual property?
Yep.
Having a binding?
It's a question of how much abstraction do you want to do, right? I'm a bit pragmatic here. Like, I want a lot of abstraction away from the view. Like, I don't want the view to know what. I really don't want the view. Ideally, these cells wouldn't even know that they need to talk to a talk detailed view model to get the other labels that they need, right? They would just have a view model that they don't know where that data came from. They don't know that it's from one model object or two model objects or what. Ideally, we have that level of abstraction. I just didn't want to. It requires a lot more work to get that nice of a clean abstraction. So to your point, like, I have done that too, where I've said, my view model isn't bindings, but instead it's a completion block. And when the view model finishes reloading all of its stuff, it just fires a completion block. And maybe the view controller just calls reload data on its table view when that fires, or something like that. Or all the labels get reset inside that completion block. Because you're right, oftentimes in this case, in pretty much all of these examples, like, I'm the wrong one. What you're talking about was whenever fetch talk finishes, every one of these values is getting set. Right. So every one of these bindings is getting called. I don't think there's a whole lot more overhead there than there would be if I just had a single interaction with the view controller. Maybe a small amount. But yeah, that's another way you could do it. If you wanted to say, okay, I changed.
There's nothing necessarily bad.
I don't think so, unless you're doing like here's an example. If in every single one of these, my view controller was calling reload data on the table view, and that's what it was doing in the fire, then every single time this happened, we'd reload the table view in like the same frame of the stack, right? So it would just be like, it would make no sense. And you could probably have a serious performance issue there. So how you use these is entirely up to what you have to do, how you need to respond to those changes.
Well, just, are you going to share your service?
It's in there, yeah. So I'll show you the service real quick. So it's a Python script that takes a JSON file and then turns it into a RESTful service. And so it's in the code, sorry, in the repository. There's a service folder with the instant API script that you can run, and it'll create a service based on source digest. Wow, I didn't want to. Yeah, so the service looks like this.
Really briefly show us the framework that you mentioned that you included at the top of this JSON.
Oh, yeah. The 360 kit. Yeah. So that's all that is in my other two branches. That I tried to get them all in sync, and it was too much of a merge headache. In my first example, I only had one app, right? It was just the app. And then as soon as you add an extension, this goes to what Kirby was talking about earlier. When you add additional targets, you need to share code between them. I built a framework, and all I did was move it. It's just not showing the right thing here. Yeah, here's the framework right here. This is not anything third party. This is just I reorganized my code so that it could be shared. Right. So this is the utility folder, which is that dynamic and a couple of extensions, and the model objects and the core data stuff, as well as the service handling and all that, and the view models themselves. So this stuff is all private, and I believe should be. I don't know if I did that right now. It's the first time making a framework, and I had to so many headaches last night. But the view models are all, or should be all public, and yeah, they're all public. So that's all the view controller, or I mean all the targets that include this framework get to use these public classes.
So, I'm trying to absorb all this, but the interaction is driven mainly by the view, right? So the view requests something and goes to the model view, and then that goes to the store.
Yeah.
And if you've got events being generated on the back end, and you want to propagate that stuff back asynchronously to the view, how would that work?
What kind of events?
Well, you've got asynchronous events coming off the device that you're monitoring, right? So you're watching this device and it's randomly firing off these asynchronous events, and you want to represent these on your UI.
So I have made a view model for IDP support once, which is similar.
Yeah.
Right. So I'm listening for notifications that the user is in and exited different beacons and stuff.
Right.
And I was doing additional things in that because, like, is this a beacon I actually want to listen to? I didn't want the view controller to know about something that we don't that they would react to.
Right.
And so yeah, I've done it again. This binding situation we have here, where here's a bunch of strings that you should associate with your labels, that is an implementation detail for this, right? That's not what view models are all about. View models are intended to just be an abstraction for those complicated data-related tasks for a view controller to, or some kind of UI to then get its information. So it may very well be that you wouldn't use strings or labels or binding or anything like that. You would use a completion handler or something like that, or an update handler, just to let you know you received new. If you think about, I'll tell you where, and this is, if you watch my video from the talk for last year, I mentioned it. My favorite class in all of Cocoa Touch is NSFS results controller with core data, because it's just so much fun to work with. And then it's a giant headache, but it's also really cool. Because you basically hand it a fetch and you say, go do this, and then it's going to tell you about changes that occur, right? And that's kind of what this does, right? But if you wanted to, you could do it exactly like that, and you could have a protocol that your view controller then implements, that's your delegation, right? You can have delegation instead in a more traditional sense and just say, you know, this many beacons just walked in or just became active, or the device just connected, it just got disconnected, it went out of range, all these kind of things, and the view controller can do what it needs to react.
Yeah, that makes sense.
Any other questions before I switch back? Specific to the code. All right. There was that code. That's basically a funny anecdote. Last year, I mentioned that quote earlier from Ash Furrow, and last year I joked about how he had kind of ruined my life because I was leading up to tell everybody about this new cool design pattern that I thought I had invented, and then found out from an article of his that no, this has already existed. It's called MVVM, and I'm an idiot. So I signed up to do this talk like as soon as John mentioned that they were doing another one of these, and on the 24th of September, Ash published a new article about MVVM and Swift, and it's basically this talk. So, he and I just need to like go drink together or something. Anyway, it's a good article for further reading. It's very similar to the way that I do things with MVVM and Swift. Yeah, so that's it. I'm here for the rest of the day, so if anybody has any questions or anything else, please come talk to me.